My dear students of class 10, I am going to start chapter 1 real number exercise 1.1 NCERT book question number 3. Question number 3 is an army contingent of 616 members is to march behind an army band of 32 members in parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Total number of members in an army contingent 616. Number of members in an army band 32. Therefore, the required maximum number of columns is equals to HCF of 616 and 32. 616 and 32. We write this as equation 1. For HCF, we follow the steps. In step 1, 616 divided by 32. We get quotient 19, remainder 8. By Euclid division lemma, dividend is equal to divisor into quotient plus remainder. So 616 can be written as 32 into 19 plus 8. Since remainder in step 1 is not 0, so we go to step 2. In this step, we divide 32 by 8, we get quotient 4, remainder 0. So by Euclid division lemma, 32 can be written as 8 into 4 plus 0. Since remainder in this step is coming 0, so we get HCF of 616 and 32 equals to 8. So by 1, the maximum number of columns is equals to 8. This is the answer of this question. Now question number 4. Use Euclid division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. For the solution of this question, we consider a be any positive integer. When a is divided by 3, we get, suppose q is the quotient and r is the remainder. By Euclid division lemma, we get a equals to 3q plus r, where r is greater than equals to 0, less than 3. Remainder is always less than divisor. So the value of r is 0, 1 and 2. We put r is equal to 0 in equation 1, we get a is equal to 3q plus 0 is equal to 3q. We put r is equal to 1, we get a is equal to 3q plus 1. We put r is equal to 2 in 1, we get a is equal to 3q plus 2. Now we take a is equal to 3q. Implies that a square of a is equal to a square of 3q. Squaring both sides, we get 9q square. 9q square can be written 3 into 3q square. We write 3 into m. The value of m here, m equals to 3q square. We take a is equal to 3q plus 1. Squaring both sides, we get a square is equal to 3q plus 1 whole square. A plus b whole square equals to a square plus b square plus 2ab. So we write 3q the whole square plus 1 the whole square plus 2 into 3q into 1. This can be written 9q square. 1 square is equal to 1 and 2 3 are 6q. So we get 9q square plus 1 plus 6q. This step can be written 9q square plus 6q in this bracket and 1 we write here. Now this 9q plus 6q, 9q square plus 6q can be written 3 into 3q square plus 2q plus 1. This equals to 3m plus 1, where m is equals to 3q square plus 2q. We take a is equal to 3q plus 2. Squaring both sides, we get a square is equal to 3q plus 2 the whole square. Using a plus b whole square formula, we write 3q the whole square plus 2 the whole square plus 2 into 3q into 2. We write 9q square, square of 2 is 4 and 2 3 is 6 2 is 12q. We write 9q square and 12q in the bracket. 9q square plus 12q plus 3. 4 is expleted. 3 and 1. So in this bracket we write 9q square plus 12q plus 3 plus 1. This can be written, we take 3 common in this bracket, can be written 3 into in the bracket 3q square plus 4q plus 1 and this plus 1. We write 3m plus 1, where m is equal to 3q square plus 4q plus 1. This is equals to 3m plus 1. Thus, a square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Now, question number 5. Use Euclid's division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. For the solution of this question, we consider a be any positive integer. When a is divided by 3, we get q quotient, r remainder. We consider q is the quotient and r is the remainder. So by Euclid division lemma, dividend is equal to divisor into quotient plus remainder. So this dividend a can be written as a equals to 3q plus r. We consider this as equation 1, where the value of r is greater than or equal to 0 and less than 3. So the value of r is 0, 1, 2. Less than 3 means up to 2. We put r is equal to 0 in equation 1. We get a is equal to 3q plus 0. Imply that a is equal to 3q. We put r is equal to 1 in equation 1. We get a is equal to 3q plus 1. We put r is equal to 2 in 1. We get a is equal to 3q plus 2. Now we take a is equal to 3q. Cubing both sides. Cube of a to the power 3 and cube of 3q the whole to the power 3 can be written 27q cube. This implies that a cube equals to, this 27q cube can be written 9 into 3q cube. This equals to 9m, where m is equals to 3q cube. We take a is equal to 3q plus 1. Cubing both sides, a cube equals to 3q plus 1 the whole cube, where we use the formula of a plus b the whole cube. A plus b the whole cube equals to a cube plus 3a square b plus 3ab square plus b cube. So using this formula, we write 3q the whole cube plus 3 into 3q the whole square into 1 plus 3 into 3q into 1 the whole square plus 1 the whole cube. This step can be written 27q cube plus 27q square plus 9q plus 1. We write these three terms in the bracket and plus 1 separately here. Now we take 9 common from this bracket. We write 9 into 3q square, 3q cube plus 3q square plus q plus 1. This equals to 9m plus 1. Here m is 3q cube plus 3q square plus q. Now we take a is equal to 3q plus 2, cubing both sides. A cube is equal to 3q plus 2 the whole cube. Again by using the formula a plus b the whole cube equals to a cube plus 3a square b plus 3ab square plus b cube. We write 3q the whole cube plus 3 into 3q the whole square into 2 plus 3 into 3q into 2 the whole square plus 2 cube. This can be written 27q cube, 54q square, 3 3 ja 9, 2 ja 18, 3 ja 54q square, 2 2 ja 4, 4 3 ja 12, 3 ja 36q plus 8. We write these three terms in the bracket and 8 should be written separately here, plus 8. So 9 taken common, we get 9 into in the bracket 3q cube plus 6q square plus 4q plus 8. This equals to 9m plus 8, where m is equals to 3q cube plus 6q square plus 4q. Thus, the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. This is the answer of this question. I will meet you next day with another set of questions. Thank you.